Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have got an isometric 3D projection of a solid, and using the information available in the 3D isometric projection, we are required to draw the three orthographic projections of the solid, that is front view, top view and the left hand side views are to be obtained. Now in order to obtain these orthographic projections, we need to evaluate the dimensions of the front view face, top view face and the side view face as they are going to appear in the orthographic projection. So once we are going to look at the solid from the front side, so we observe that the front view of the solid will be involving the width of the solid, and this width of the solid happens to be 60 millimeter. So this is the width of the solid, and the height of the solid, this is equal to 90 millimeter. Now here we have 10 millimeter corresponding to the bottom width, then 50 millimeter is the height of the middle component over here, and 30 millimeter it is the height of the top portion of this particular solid, right? So 30 plus 50 plus 10, 90 millimeter over there. So the front view face will be having the dimensions 60 millimeter by 90 millimeter. Now looking at the solid from the top, so from the top when we are looking at this solid, so we are going to have the width of the solid, it is equal to 60, and the depth of the solid, it is also equal to 60. So since this is a cylindrical object, so whatever is going to be the width, so same depth of the solid will be involved over there. So the top view will be a square, that is involving 60 millimeter by 60 millimeter edges over there. Then as we move on to the side view, so in the side view we are going to get the depth of the solid, which is again equal to 60 millimeter, and the height of the solid will be equal to 90 millimeter. So having obtained the dimensions of the front, top and the side view faces, now let us see what are the surfaces which will be visible when we are looking at the solid from the front side, from the top side and from the left hand side over there. So when we are going to look at the solid from the front side, so these are the four faces which will be visible to us. So the four surfaces, they are surface number 1 corresponding to this bottom block, surface number 2 corresponding to this rectangular slot which is there in the second element of this component, then third surface will be it is the remaining portion of the second element which is excluding this rectangular slot. So this portion will be referred to as surface number 3. And then you have the top surface corresponding to the third element of the solid. So this is the surface number 4. So as we look at the solid from the front view, so please see this is a circular portion. So the projection of this circular portion, it will be corresponding to this diameter. So corresponding to this diameter, so this circular portion will be appearing as a rectangle in the front view onto the vertical plane. So this will be appearing as a apparent shape over there. Then the surface number 2. So here we have surface number 2, which is a rectangular block. So since this rectangular block surface or a slot surface, it is parallel to the vertical plane, so we are going to observe this rectangular slot as a true shape onto the vertical plane. Then we have the surface 3, which is a circular portion over here. So since this is a circular portion, so once again it will be appearing as a rectangle corresponding to this diameter of the element number 2. Then the surface number 4, so again it is a circular surface, so it will be appearing as a trapezoid onto the front view. So again it is an apparent shape over there. Now when we are going to look at the solid from the top, so the surfaces which will be available will be surface A, surface B and surface C, and we can see that looking from the top, so surface number A, it happens to be parallel to the horizontal plane. So the true shape of the surface A will be viewed onto the horizontal plane, whereas this is a sloping surface. So even though it's a bigger surface, but so it will be appearing as a shorter surface onto the horizontal plane because of this inclination of the surface. So we are going to view the apparent shape or a smaller shape corresponding to the surface B onto the horizontal plane. And finally the surface C. So surface C also happens to be parallel to the horizontal plane. So onto the horizontal plane we are going to obtain the true shape of the surface on the horizontal plane in the top view. Now when we are going to look at the solid from the left hand side, so once again this is a circular surface. Now corresponding to this diameter we are going to view this P surface as a rectangle onto the profile plane. So this surface will be appearing as the apparent shape onto the profile plane. Similarly, surface Q, this is also the curved surface over there. It's a semicircular surface. So once again, it will be viewed as a rectangle in the profile plane. So this surface Q will also be appearing as the apparent shape in the profile plane. And similarly, since you have surface R, which is not only circular but it is also inclined, so it will be appearing as a trapezoid in the profile plane. So this surface projection, that is surface R, will be projected as apparent shape onto the profile plane. Now let us start with orthographic projections over here. Now here we have the solid whose projections they are available. Now we are required to draw front view, top view and left hand side view of the solid. So since left hand side view is to be drawn, so left hand side view will be projected on the right hand side. So over here we are going to have the front view of the solid above the XY reference line. The top view of the solid will be drawn below the XY reference line, and the left hand side view will be drawn onto the right hand side. So let us start with the construction of the front view projections of the solid. Now as we look at the solid from the front side, so these are the four surfaces which will be visible to us: surface 1, surface 2, surface 3 and surface 4, right? So now we have got the dimensions of the front face of the solid will be 60 millimeter, it is the width of the solid, and 90 millimeter is the height of the solid. So we have drawn a rectangular portion over here where the width has been mentioned as 60 millimeter and the height of this rectangular front face of the solid, it will be equal to 90 millimeter. So the height of the front face will be 90 millimeter and the width of the front face will be 60 millimeter. Now this horizontal projection will be carried forward to the left hand side view, because in the left hand side view also the height of the solid will be required. Similarly, the width projections, they have been extended onto the top view projections, because in the top view we require the width of the solid besides the depth of the solid. Now let us plot the depth of the solid. So depth of the solid will also be equal to 60 millimeter because it is a circular construction at the bottom over here. So this circular construction is having diameter is equal to 60 millimeter. So this can be inscribed into a square of 60 millimeter edge. So the depth of this solid will be again 60 millimeter. So the width is also 60 and the depth is also 60. And now we can transfer this depth onto the left hand side view. So in the left hand side view, the dimensions of the rectangular surface will be, that is depth, it is equal to 60 millimeter and the height, it is equal to 90 millimeter. So with this we have completed the construction of the front rectangular face and the top view rectangular face and the left hand side view rectangular face over there. Now we know that this height of the lower block, it is equal to 10 millimeter. So this height of the bottom block over here right? So it is equal to 10 millimeters. So corresponding to 10 millimeter height, I have marked this distance of 10 millimeter. So we have drawn a projector line over here which will be extending from the front view to the left hand side view as well. So this bottom block has been drawn over here. So because this particular, you see, even though it is a circular block, but it will be appearing as a rectangle in the front view. So this will be my diameter. As I am looking at the solid from the front view, so this diameter will be considered over here. So corresponding to this diameter, so this block number 1, it will be appearing as a rectangle. So the projections of surface number 1, they have been obtained over here, and this is an apparent shape because original block happens to be a circular block. Now we know that this particular portion, that is element 2, so this was the element 1, that is the bottom block. Then you have the element 2 of this particular component. So element 2, it is this circular portion having a diameter equal to 30 millimeter. So the bottom block was having diameter equal to 60 millimeter, and the second element is having, it is a circular portion having a slot over there, right? It's a circular portion having a slot. Now this second element is going to have diameter equal to 30 millimeter, and the height of this second element is equal to 50 millimeter. So what we have done, starting from here, that is from the top of the bottom block, we have drawn another 50 millimeter height so that I can locate this intersection of element 2 and the element 3 over here. So this is my top face of the element number 2, which will be located at a height of 50 millimeter above the top surface of the element number 1, right? So this portion has been located over here. Now let us start with the construction of, that is the top of this rectangular slot. So the top of this rectangular slot, it is marked by this height of 35 millimeter above the top face of this element number 1. So this height of the rectangular slot happens to be 35 millimeter from the top surface of element number 1. So from the top surface of element number 1, now I have marked 35 millimeter. So please check, I have marked the height of 35 millimeter. So this will give me the height corresponding to this particular rectangular slot. Now having drawn these parameters, now I need to draw this slot over here. So what are the dimensions of this slot? Height is equal to 35 millimeter and the width of the slot, it is equal to 10 millimeter. So what I have done, I have worked out the axis point or the midpoint along the width of this particular component. So this is the center point along the width dimension over here. So having obtained the center point, what I'll be doing, I'll be taking an offset of 5 millimeter towards left side and 5 millimeter towards the right hand side, so that I get the width of this rectangular block equal to 10 millimeter. So this is my surface 2. Please check. This is my surface 2 which I have obtained over here. So later on I will be darkening this portion of the surface number 2 over here. Okay, so the rectangular slot true shape has been obtained and the apparent shape of the surface number 1 has also been obtained. Now the next thing is I need to draw the true shape corresponding to the bottom block over here. That is the outer diameter. This is equal to 60 millimeter over here. So the outer diameter of this bottom block, it is equal to 60 millimeter. So I have already obtained the center along this width side as well as along this depth side also. So this is my depth side, this is my width side. So once I obtain the center point, so from the center I'll take the radius equal to 30 millimeter or diameter is equal to 60 millimeter. So once I draw this circle, it means that I have been able to draw this true shape of the outer portion of the cylindrical element number 1, So this is my cylindrical element number 1 having diameter is equal to 60 millimeter. Now I can draw the surfaces of the cylindrical portions corresponding to the top face of the element number 3, which is having diameter is equal to 20 millimeter, and the top face of the element number 2 over here, right? So this is the top face of the element number 3, which is 20 millimeter diameter, and this is the top face of the cylindrical portion which is corresponding to element number 2, and this is having the diameter 30 millimeter. So here I have drawn this portion, that is top portion of the element number 3 I have drawn having the diameter is equal to 20 millimeter. So this diameter I have drawn as 20 millimeter. So this is the 20 millimeter. So once I draw this 20 millimeter diameter, so what I am going to do, I am going to project this 20 millimeter outer dimensions over there, that is this diameter outer projections. I will be taking it up to the top point of the front view, so that I will be able to obtain these 2 points in the front view where my slanting portion of the circular element will be starting. Okay, so this is the starting point of my circular portion corresponding to the element number 3. Now I have to obtain this portion also in the front view. So in order to obtain this portion in the front view, what I need to do, I will be drawing a circular portion top view corresponding to the top face of my element number 2. So element number 2 is a cylindrical portion having diameter is equal to 30 millimeter. So I will be drawing a circular construction over here having outer diameter equal to 30 millimeter. Now this corresponds to this circular element number 2 over here. This is the outer portion of the element number 2, and having drawn the circle in the top view, now these projections now I am going to take up so that I am able to obtain the bottom point of the element number 3 over here. So this was my slant circular portion. So the top portion I had identified earlier. Now the bottom portion I have identified through the construction of the circular projection corresponding to the top face of element number 2 over here. Now I can now join this end with this end, and this end can be joined with this end over here. So please check, I have darkened the projections corresponding to the element number 3 in the front view, right? So these projections, they have been obtained, and I had told you earlier that this will be appearing as a trapezoid in the front view. So I have been able to obtain the apparent shape of surface number 4 in the front view. And another thing we should remember, the moment I had drawn this circle portion over here with a diameter of 20 millimeter, I had obtained the true shape of the surface A in the top view. So this was the true shape which was obtained in the top view while I had drawn this construction of circle having diameter is equal to 20, and then while drawing this circular portion having diameter equal to 30 millimeter, so this sloping section was obtained, that is this sloping section top view I was able to obtain. So now we can see it is a big surface over here, but into the top view it has been projected as a smaller section over there. So this is a section between A and B. So this section is there which represents my surface B, and this is the apparent shape of the surface B, because this surface B, it is much smaller than the actual construction which is appearing in the isometric projection over there. So this is the apparent shape, and then the moment I have the gap between these two circular cross sections over there, that is between this element 2 and this element 1. So whatever is this gap, so this gap is my surface number 3 C over here. So this is my surface number C, and surface number C has been projected as a true shape onto the horizontal plane. So surface A is true shape, surface C is true shape, while surface B, it is the apparent shape of this surface over there. Now let us complete the front view as well, because all the construction is completed. So this is the projection corresponding to the element number 3, this one. These are the projections for the element number 2, which is a cylindrical portion having diameter is equal to 30 millimeter, and within this I have got a rectangular slot which is parallel to the vertical plane. So this gives me the surface 2. So surface 2 is appearing as true shape onto the vertical plane, whereas surface 3, it is this surface. So this surface, it is a cylindrical surface and it appears as a reduced cross section in the front view. And finally I have got this bottom block. So bottom block is having diameter is equal to 60 millimeter, or the width, it is equal to 60 millimeter, and height is equal to 10 millimeter. So this bottom block represents my surface number 1 over here. So this is surface 1, surface 2, surface 3 and surface 4. So let me mark these surfaces in the front view. So similar to the front view, I need to obtain the top view also. So in the top view we have obtained face A, face B and face C. So face A and C, they were the true shapes, whereas face B, it happened to be the apparent shape. Now let us move towards the left hand side view. So left hand side view will be appearing on the right hand side. Now we have these circular cross sections corresponding to the upper part and corresponding to this middle part over there. So these projections, they will be now shifted to the side view over there. So please see the circular portion corresponding to this surface A. So this portion has been shifted onto the left hand side view. So from the left hand side view, which diameter will be visible? This one. Whereas in the front view, this diameter was visible. In the side view, this diameter will be visible. So diameter sizes, they will be equal, only the orientation they have changed. So side view will be giving us this particular side of the diameter. So these 2 points, they have been obtained over here. Now let us obtain the bottom points of this inclined circular cross section. So we need to transfer these 2 points into the left hand side view. So let us do it. So these are the projections corresponding to this particular surface, corresponding to element 2. This is the top surface which is having the diameter equal to 30 millimeter. So let us take these projections up. So these 2 points are the points in which I am interested, this one and this one. Similarly this one and this one. So same way, the bottom block now can be obtained, height of 10 millimeter and the depth, this is equal to 60 millimeter. So depth is 60, height is 10. So this gives me the apparent shape of surface number P, and which diameter I am talking about. From the side view, I am going to talk about this diameter. Okay, so this is the diameter we are talking about. Now the cylindrical portion we can draw. So again we have the cylindrical portion, but now the slot is not visible to us over here straight away. So there is a slot which is running perpendicular to this left side view dimension or the direction of viewing over there. So here no slot will be available as such. Rather, this slot is running across this particular, you see, cross section perpendicular to the cross section over there. So this portion should be drawn as a dotted portion over there. This portion will be drawn as a dotted portion. Why? Because this slot is running through and through. So since slot is running through and through the solid, so this portion will be drawn as dotted, right? Because this slot is not visible from the side view. So please check, this portion has been drawn as dotted one. Okay, and then this top canopy, that is the element number 3, will be once again appearing as a trapezoid in the side view. So this is how we can go about construction of the left side view. So this is my surface P, apparent shape. This is my surface Q, this surface, again apparent shape. This is my surface R, it is this surface over here, this one. So this is again apparent shape. So this way we have been able to obtain all the projections, that is the front view projection, top view projection and the side view projections of this solid. Now let us remove the redundant dimension, because total was given as 90. So 10 plus 50 plus 30, this is also 90. So one dimension I have eliminated, and now I can take off these faces over there so that the better visualization of the orthographic projections can be obtained. And similarly, I can remove these marking of the surfaces from the isometric projections so that better interrelationships and understanding regarding the correlation between isometric projection and the orthographic projections can be obtained. Right? So this is all for today. So I hope that through this discussion you would have clarified about the procedure how to draw orthographic projections once the isometric projections of the solid they are available. So thank you very much. Thanks a lot.